Hi, my name is Matthew, and in this video we're going to talk about multiplication and division of rational expressions. The multiplication and division of rational expressions is not all that complicated. However, it is made particularly difficult if you don't have a good foundation in an ability to factor. And what we're seeing in this first problem is a multiplication of rational expressions. I know that they're rational expressions because each of these fractions has a variable in the denominator. So for me, that's what makes it a rational expression. And I'm seeing a lot of opportunities to factor. And what we're going to do overall is we're going to factor as many of these expressions as we can in the numerator and denominator, and then we're going to do some canceling, and then we'll present as a final answer. So let's see what we get. In the first numerator, x to the third minus 27 is a difference of cubes. If you don't feel comfortable factoring a difference of cubes, do a quick search. I definitely have examples in other videos of factoring differences of cubes, sum of cubes, perfect square trinomials, and the like. So you can find those on my channel or elsewhere for sure. This one factors to be x minus 3 times x squared plus 3x plus 3 squared, which is 9. In the denominator, we have a difference of squares. Let's make this a little bigger. In the denominator, a difference of squares, x squared minus 9, that factors into x minus 3 times x plus 3, or x plus 3 times x minus 3. The order doesn't matter. In the next numerator, we've got x squared minus 6x plus 9. I'm going to write this, as it turns out, that's a perfect square trinomial. If I take the square root of this and the square root of this, I multiply them together and double them, I get 6x. Now it's a minus 6x, so I'm going to have to use a minus 3. And really I could write this as x minus 3 squared. I'm going to write it as x minus 3 times x minus 3, just in case that makes it easier for me to cancel stuff out. And in the denominator, x squared plus 3x plus 9 is not a perfect square trinomial because this is a 3 and not a 6. And as it turns out, that is not factorable. You could use the 1 as your a value and the 9 as your c value and attempt to factor using the AC method, and you'll find that there is no factor pair available to split the middle term. The process of factoring using the AC method is in another one of my videos, and I will do my best to go into the description of this video and put links to those so that you can reference those more conveniently. But since it can't be factored, I will just write this into this denominator, leaving it right where it was. Great. And then it's time to start reducing. Pretty obviously, this x minus 3 and this x minus 3 reduce. And this x squared plus 3x plus 9 cancels with its similar factor in the other denominator. Now, does that constitute cross-canceling, or is there some kind of a special language that I should use, considering that I canceled the numerator from one fraction with the denominator of another fraction? You don't really need to put any kind of a special note that describes what you did, because, as I think you'll agree, 2/3 times 4/5 is equal to 8/15. How'd you get that? Well, you took the 2 and multiplied it by the 4, and the 3 times the 5, and then you did the multiplication and you got 8/15. You just typically skip this step in your head. You don't think of it as being the two numerators multiplied together over the two denominators. You jump right to the 8/15, which is fine. But what I'm trying to illustrate here is that, and I should really change the, let's see, not my best example ever. Let me make a little change here. You don't have to be writing this down. So let me change those 4s to 7s, and then I'll change the 5 to a 6, or for that matter, we could just change it to a 2. There we go. Now, here, certainly we could cancel out the 2's because it's a numerator and the denominator of the same fraction. They're still the numerator and denominator of the same fraction. When they're connected by multiplication, you can imagine just kind of smashing them together. And then the ability to cancel out the 2's here isn't as surprising. It's the same as the ability to cancel out the 2's here, which is why it's the same as the ability to cancel out those x squared plus 3x plus 9 factors from those two different fractions. All right, now that I've drawn yellow highlighter lines over the top of everything, can I get rid of all of this stuff? I don't need any of that. All right, I need that. Put that back. There we go. All right, so let's cancel out the x minus 3's again and these larger factors. There we go. And we can write our final answer now as x minus 3 squared over x plus 3. I don't need the parentheses in the denominator anymore because I'm not really protecting the x plus 3 from anything. There's nothing that needs to be distributed in. I don't need to be squaring it or anything, so I can just write it as x plus 3. But you can see how important the ability to factor is in order to be successful in multiplying and simplifying. You'll also note that I did not actually look at the instructions for this right here. What does it say right there? Multiply. Guess how much multiplication I did? 0. Not a little bit of it. All I did was factor and cancel stuff out. If I needed to multiply, if I could have multiplied, I would have done that last, not first. That takes me back to the same example that we were talking about in red a second ago, which was 2 over, I don't remember what this was, 2 over 3 times 5 over 2. Should I write this immediately as 10 over 6 and then reduce? I could, but why not just cross out these 2's immediately, skip this, and go to the final answer of 5 over 3? That way I don't have to do any multiplication at all. If I can avoid doing the multiplication, I'm going to. Now, we'll have an opportunity to do that, I believe, a little bit here in problem number 5. Except this says division. And what you need to know is that division is the same thing as multiplying by the reciprocal. And if you need to find a marker board and write that phrase over and over and over again until your hand starts to cramp, then so be it. And if you need to write it in dry erase marker on the bathroom mirror so that you see it while you're brushing your teeth, do that. If you want to write it on a piece of paper and tape it up over your desk so that you see it every time you glance up while your mind is wandering and you're reminded, do that. Do all of those. Division is the same thing as multiplication by the reciprocal. So that's the very first change I'm going to make here. 50x to the 11. Let's make it look like an 11. Now it just looks like scribble. Let's try that again. There we go. Over 30 times y to the 8 times, and then flip this fraction. We've got 30y to the 3rd on top, 30x to the 6 on the bottom, and now we can proceed. Could I have done some canceling before changing to multiplication by the reciprocal? Yes, but I wanted to use this division problem to immediately point out to you the importance of the ability to use that maneuver. I just had a thought that it's almost like castling when you're playing chess. That ability to take your king and one of the rooks and do this little switchy kind of maneuver where they almost trade places, but they get a little bit closer together. I feel like it's kind of like that. It's a very special scenario when we're able to use this particular maneuver. Okay, enough talking. Let's keep canceling. Now that we're multiplying by the reciprocal, let's cancel some stuff. In the number 50, there's a multiple of 10. And in the number 30, there's a multiple of 10. And I'm going to cancel out those multiples of 10 by crossing out those zeros. In the number 30 and 30, oh wait, 30 divided by 30 equals 1. So we can get rid of those entirely. Goodbye. Now from here, it's kind of up to you. What I see next is, let's get another color involved here. What I see over here are 3 factors of y, and down here I see 8 factors of y. So I'm going to remove 3 of them from the numerator. Those are going to be gone, and they're going to cancel out with 3 of these from down here, but I'm going to have 5 left. So I'm going to write in a little y to the 5 down here. And something similar happens with our x variables. I've got 6 multiples of x down here and 11 of them up here. So these 6 on the bottom are going to cancel out, gone, and they're going to cancel out 6 of these 11 in the numerator, leaving me with only 5 of them, so I'm going to write an x to the 5. Now the other way that you could do that is upper exponent minus lower exponent. So you could have done 3 minus 8 gives you y to the negative 5, and then push that into the denominator as a y to the positive 5, which is what I wrote right here. So if you want to use that technique, you are welcome to. Same thing is happening with my x variables. I've got x to the 11 here and x to the 6 here. What's 11 minus 6? X to the 5. Oh wait, that's what I wrote right here. So again, if you want to use that strategy or technique of subtracting upper exponent minus lower exponent, it will work. You can use that technique. Alright, let's clean this thing up because it's really starting to look like a mess. What do I have left? In the numerator, I've got a 5, and an x to the 5, and the 30 is gone, and the y to the 3rd is gone. That's it. In the denominator, I see a 3, I see a y to the 5, this 30 is gone, this x to the 6 is gone, so that's it. And this becomes our final answer. So just take it slow, be organized, rewrite the thing as many times as necessary as you cancel stuff out until anything that can go is gone, and whatever's left is your final answer. Don't let this division problem intimidate you. It's not a division problem. It's a multiplication problem. We are immediately going to multiply it by the reciprocal. This is going to be writing intensive, so I apologize. There's going to be some silence while I'm doing some rewriting of these things. You should be rewriting these things, and if all goes well, you're watching this video at double speed anyway. I think I speak slowly enough and I try to be articulate enough that you can get away with watching these videos in double speed and then just slow them down or pause them and rewind them and rewatch them if there's something that's really important that you need to see again. But otherwise, I say, speed it up, especially when I'm doing all this writing. When I go through and watch these videos and I'm doing some time stamping, I certainly watch them at double speed. I've got no interest in seeing myself at normal speed. It's like torture. Okay, so again, all I did, and you should be putting some kind of a note in here, and you should have put a note in up here that says that we went from here to here because we changed division into multiplication by the reciprocal. And so here we have done multiply by the reciprocal. Nice. And now we're going to factor, 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 factor. And I think we can do that. I think we can actually factor this one 4 times. My first numerator is, again, a difference of cubes. Surely you recognize that 27 is 3 to the 3rd. Y to the 3rd is y to the 3rd. 512 might not jump out at you, but that is 8 to the 3rd power. It's 2 to the 3rd to the 3rd, 2 to the 9th power. In other words, 8 to the 3rd. I'm a math nerd. These things jump out at me. So let's factor that one, as long as we're talking about it. We have 3y minus 8 times 3y squared, which is 9y squared, plus the 3y times the 8, which makes 24y, and then always plus, so we need 8 squared, which is 64. That's our first numerator. In the denominator, it almost looks like it wants to be a difference of squares because I see the y to the second power. Oh, but that's because it was a typo. It's actually y to the third power. That was a close one. There we go. Now it's a difference of cubes. Perfect. 512. We already talked about it. It's a perfect cube. 125 is 5 to the third. That's a perfect cube. So let's factor this. We get, that is an 8y minus 5 times, we need 8y, quantity squared, which makes 64y squared. And then 8 times 5 is 40, or 8y times 5 is 40y, so there's plus 40y. And the always plus, and then 5 squared is 25. Great, and then let's move into our second fraction. The new numerator in our second fraction is 64y squared plus 40y plus 25. Yikes. Is that some kind of a special factorable expression? What I'm hoping is that it's a perfect square trinomial. And what jumps out at me that suggests that it might be is I see 64 is a perfect square, y squared is a perfect square, and 25 is a perfect square. So let's test this and see if it's a perfect square trinomial. The square root of 64 is 8, and the square root of 25 is 5, and 8 times 5 is 40. And if you double that, you get 80, except this does not say 80. It says 40. If it had said 80, it would be a perfect square trinomial. But it does not say 80, so it is not a perfect square trinomial. And in fact, it can't be factored at all. But I'm not all that sad about it because we're going to be getting rid of it anyway. In a moment, we'll be canceling it with this factor from our first denominator. But let's not start canceling stuff out just yet. In our second denominator, we've got 9y squared minus 64. 9's a square. Y squared is a square. 64 is 8 squared. This is a difference of squares. And when we factor it, we get 3y plus 8 times 3y minus 8. Now we have factored everything as much as possible, and so we can start canceling some stuff out. In the top left, well, let's get rid of these big guys first. I see the 64y squared plus 40y plus 25 cancels out with this one from the first denominator. And in the top left corner, I see a 3y minus 8. And in the far bottom right corner, I see a 3y minus 8. Those are gone. And I think that's it. Don't worry about trying to factor this thing. Nor should we have even thought about factoring this, because we should not have thought about factoring this. And the reason I say that is because when you have a difference of cubes like this, and you factor it into this times this, the vast majority of the time, those two things will not be further factorable. Unless you were dealing with y to the 6th power or something. But when your exponents are just normal cubes, so to speak, that's as far as you'll be able to factor it. So I don't have to worry about further investigating factoring anything. And we can write ourselves a final answer. I would write my final answer, and I would expect that your final answer is going to appear in factored form. So 9y squared plus 24y plus 64 over, and then here's where I would leave it factored, 8y minus 5 times the 3y plus 8. It's not a lesson in foiling and combining like terms. It's really a lesson in factoring, canceling out, being organized, and doing this keep change flip. In other words, multiplying by the reciprocal. Is it possible that a multiple choice answer would have the denominator foiled and combined like terms? Would you have to multiply that out? Maybe. I'd say that that's atypical. And do I have anything else to share with you in this lesson? I do not. So, what are the big takeaways from this? Certainly that division is equivalent to multiplying by the reciprocal. Also that you should try to cancel or reduce first and then do any necessary multiplication, which we didn't run into a lot of. And really those same principles apply in the first practice problem that we did. So get good at your factoring. I will try to put links to some of those other factoring videos that I've made in the description of this video in case you want to use those for reference. Otherwise, that's it for this one. I'll see you next time. Thanks.